Hi student, welcome to Thermodynamics Lab. Title of our today's experiment is, to validate Zeroth law of thermodynamics, by establishing thermal equilibrium between given bodies. This is our outline for today's experiment. First we will discuss what is Zeroth law of thermodynamics, what are the applications of Zeroth law, what is thermal equilibrium, what is the apparatus required for performing this experiment, what experimental procedure we will adopt at the end. An observation table for reading will be displayed. What is Zeroth law? Zeroth law of thermodynamics tells us the concept of temperature. This law states that, if two bodies are each in thermal equilibrium with a third one, then they are in thermal equilibrium with each other. Consider an isolated body filled with a gas, insulated with a boundary from its surroundings under an adiabatic process, a process where no heat transfer takes place. Since no heat transfer takes place between the body and the surroundings, and all the macroscopic properties of the body, that is, pressure, volume, temperature, mass remain constant. Therefore, we can say that it is in thermal equilibrium with its surroundings, and the body has become an isolated system. There are also various ways to state the Zeroth law of thermodynamics. However, in simple terms, it can be said, systems that are in thermal equilibrium exist at the same temperature. Zeroth law of thermodynamics takes into account that temperature is something worth measuring because it predicts whether the heat will transfer between objects or not. This is true regardless of how the objects interact. Even if two objects are not in physical contact, heat still can flow between them, by means of radiation mode of heat transfer. Whereas, Zeroth law of thermodynamics states that, if the systems are in thermal equilibrium, no heat flow will take place. Thermal equilibrium. A particularly important concept is thermodynamic equilibrium. In general, when two objects are brought into thermal contact, heat will flow between them until they come into equilibrium with each other. When a temperature difference does exist, heat flows spontaneously from the warmer system to the colder system. Heat transfer occurs by conduction or by thermal radiation. When the flow of heat stops, they are said to be at the same temperature. They are then said to be in thermal equilibrium. You leave a thermometer in a cup of coffee. As the two objects interact, the thermometer becomes hotter and the coffee cools off a little until they come into thermal equilibrium. Two objects are defined to be in thermal equilibrium if, when placed in thermal contact, no net energy flows from one to the other, and their temperatures don't change. Applications of Zeroth law. Now when the thermometer comes in contact with a hot body, a person having fever, its temperature rises. After few seconds, this mercury and human body will be at the same temperature. Thus we can say that they are in thermal equilibrium with each other. Let's say the surrounding temperature is 25 degrees Celsius and the temperature of hot coffee is 70 degrees Celsius. Then coffee will lose its heat until its temperature reaches 25 degrees Celsius. In other words, coffee will lose heat until it achieves thermal equilibrium with the surrounding. Vegetables in your refrigerator will cool down and it will achieve the lower temperature as that of the air inside the refrigerator. We can say that the vegetables are in thermal equilibrium with the air of the refrigerator. A thermostat in your room shows 68 degrees Fahrenheit, which means that the air of your room and thermostat are in thermal equilibrium with each other. All the objects of your room, clock, cupboard, chair, table, fan, etc. are also at 68 degrees Fahrenheit according to Zeroth law of thermodynamics. Apparatus required. We require following few equipments. Saturated NaCl aqueous solution at lab temperature. Hot water. Normal water 500 ml beakers. 2 100 ml beakers. Thermometer. Experimental procedure. In a suitable container, large beaker or a large dish, put hot water to a high temperature, between 50 degrees Celsius and 70 degrees Celsius. Call this water system C. In a 100 ml beakers put about 50 milliliters of water at lab temperature. Call this system A. In another 100 ml beaker put about 50 milliliters the saturated NaCl solution at laboratory temperature. Call this system B. Put both systems A and B inside the system C. After some minutes, measure the temperatures of system A and system C, and once both systems have the same temperature, record the values as T system A and T system C. Also, measure the temperature of system B and system C, record the values. This is the observation table for this experiment, in which we will record the temperature of all three systems.